Thank you for joining Sertl Optics 360 Pulse. I'm your host, Jennifer Sertl, Director of Marketing. 360 Pulse imaging is part of everyday life, and Sertl Optics technology is being designed to accelerate the delivery of life-saving resources, ensure aerospace safety, and also increase immersive experience participation. This podcast, 360 Pulse, is dedicated to featuring immersive technology and innovators working on these capabilities. Today's guest is Mark Tolbert, president of Toptica Photonics. He has a strong engineering and management background from the University of Rochester and a degree in physics and an MBA from the Simon School also. He started his career in plastic optics as director of sales and marketing for Germano Simon Corporation. His management interest and skills brought him to a leading position where he's been doing business development with particular emphasis on scientific product lines and international business. And then it ended up that he ended up leading Toptica, and he will tell us a little bit about that. Welcome to the program, Mark. And did I mention the company correctly, or can you correct the sound of that company you were part of?
Yeah, no problem. And thanks for having me here today, Jennifer. That was Germano Simon Corporation, or GS Plastic Optics. So that was my first real gig coming fresh out of college.
That's, and so it's really neat having you come from the expertise of optics here in Rochester and then begin working for international companies. So we'll go ahead and jump right in if you don't mind. I'm curious to know what inspired you to pursue a career in optics, and how'd you get started in the first place?
It was all complete last minute decisions, kind of. So as I was finishing high school, I actually had a pretty strong desire and drive to be a part of the space program. So I had headed down the Air Force path, and make a long story short, I ended up not heading into the Air Force Academy, and last minute decided that I would go study physics because it was something that was hard. And between choosing the schools that I could afford and the ones that accepted me, I ended up doing a degree at RIT, which then led to bringing that focus in optics. So a little bit of focus on the physics, learn some science, and then figure out how the heck I get a job.
So it's really interesting that your background, it kind of does weave in University of Rochester as well as Rochester Institute of Technology, and our team has actually leadership from both as well. So that's really interesting. And it's interesting so this is kind of your backup position. Is that what I'm hearing you say?
It was. It actually, no regrets. So I'd still love to do a space mission at some point, but I think due to corrected vision, I knew I'd never fly in the Air Force. So I had to figure out something to do. And because this was all legacy pre-1994 when they allowed corrected vision to happen.
Oh, wow.
So yeah, physics was it was a backup, but I've got to say it turned out awesome. And I've still been just blessed to be engaged in so many different things. And when you talk about the experiences at RIT and U of R, both were transformational. I mean, RIT this was back in the day when it was a quarter system still. It really got you to a level that you were ready for industry. And that's something that I super, super, super appreciated. I'm not sure I loved the social engagement that I might have expected in college because of it, but it was a great prep tool. And then I didn't go back to U of R until I had started my career. So it was my second real position when I got into that role. And that was just as immersive. And I got a little bit of both experiences at the same time. But Rochester has so much to offer with the educational entities that we have here that, I mean, they're just world class. And that made so much of a difference in the things that I've done in my life.
So I think because my daughter also is taking physics and organic chem and all of that, I feel like anytime you choose those kind of classes, you make a decision of what your college experience is going to look like relative to the social versus real world, which is great. So, well, now that you have been a student in it, a practitioner in it, what do you think some of the biggest challenges facing the OPI industry are today, and how are you preparing your company to deal with these challenges?
Yeah, the biggest challenge is people. It probably always has been and continues to be, but it's getting enough good, qualified people in the roles. In today's industry, people is the most important thing that we do, and that's always been the case. But there's so few of them right now that are available that we're just competing for great talent. So I think that's the number one challenge that we're facing. We can deal, and our industries, I think, can deal with most of the rest of the pressures with inflationary changes and everything else that's happening. But it's getting good people in the door and getting them to understand what they're going to be doing. So, and we talk about physics and optics and everything else, but in most of the cases, I've had to learn that it's a transition. You learn a language, and then you have to apply that language to whatever it is that you do, and that's not always obvious. So, we do a lot with quantum technology right now. We've been doing that for over 20 years. Up until a couple of years ago, most of the world didn't even know what quantum was, or they were just afraid of quantum mechanics in college. Now it's becoming mainstream. So we have to teach chemists, we can teach electrical engineers, we teach them the language that cross the barrier to get into the quantum industry, for example. So it's letting them realize that, okay, when you're going through school, you pick up a base set of skills, and then you evolve that towards the work that you're doing. And it's just getting good, smart people. I think there's some other changes, and this might be the old guy in me that comes through and talks through some of the cultural changes that have happened as I've grown older, the cultural changes that have happened due to COVID. That desire to drive lifestyle now is a little bit different than it was 5 years ago. And those types of things, those are a component to it too, but I think the industries will work through that. And then I think one of the last things that ties to the people as well is really immigration and export control. When you look at the people that have the educations that we're looking for, a good 60% of them aren't from this country. So in many cases, it's having some reform there could really help that. And again, all of that ties back to people being the number one challenge for the photonics industry today.
And, the next two questions, I hope for our students and potential employees that are out there, there's a couple of questions that might make you even more interested to work in this technology. One, it's really exciting to hear technologists value human capital. And also the idea that no matter what people got their degree in, they will have to continue to learn, which I'm hearing you say is that there's even with the engineers and mechanical engineers and the people that are on your team, they're probably learning a whole bunch about quantum right now, just because the field itself is growing so much. So can you give us, I'm not sure what's confidential, what's not confidential, to the degree that you can. I'd be really interested in an exciting project your company's working on and what impact it has on society, or if we just learned the impact of the technology that you're working on.
Sure. So here at Toptica, we focus primarily on lasers and the technologies that are around lasers. So if you think of what that means, we're creating light for various applications. And we've always had a very strong direction of making sure that we provide the best light. So we're not making laser cannons. We're not blowing things up. We're not cutting things. We're designing lasers that go into applications that have the highest of precision. So we're talking 10, 15 digits, sometimes 20 plus digits to the right of the decimal point if it's locking, or just super solid laser technology. We focus that technology in three major markets, and we heavily focus on quantum technologies. We've been doing that since, almost 25 years now. Biophotonics is another area, and then what we classify as materials. So in the materials aspects, we're typically using the laser to either look at or do something to the material for inspection. But for the past couple of years, since about 2017, since the drive of the National Quantum Initiative, that industry has just exploded. And despite the fact that 25 years ago, our very first laser was made for the quantum industry, Bose-Einstein condensation, so many people didn't even know what it was until there was a commitment by the federal government to drive quantum commercialization. Now, there's a couple of different parts of quantum. So one side is superconducting, and that's getting the materials side into quantum technologies. And that's not something that we do at all. We focus all on photonics-based or light-based quantum technologies. And there you can be dealing with quantum computing, quantum communication, quantum encryption, quantum sensing. So there's so many exciting things that are happening there that essentially we're almost at the same level as the introduction of the transistor in 1945. Mm-hmm. If you think about what the qubit is going to mean to the world in another decade from now, let alone today, it's just groundbreaking changes that we don't even have a clue yet. So we're learning how to make quantum computers. We're learning how to create GPS replacement with quantum sensing. But it's the side effects of all of that that really has a dramatic impact on society. So that's just one area that we look at as being a huge tech push that people can learn a ton about. And there's so much transformation in all of the other disciplines that'll come together to help drive that. And that's before we even start talking about biophotonics and semiconductor.
I'm like, I need a breath. I don't know about you, but I need a breath with all of that. So, like, if I'm hearing you right, that the impact would be that if we do some of this with lasers, it impacts the waste that's created to actually carry. Can you help me, like, just in case people are not versed in this? I'm trying to make it street smart. So, can you help me do that?
So I'll give you some examples of each of them. So everybody knows that GPS is vulnerable right now. So we get a GPS network that's in place that if something global were to happen and that system went down, it would just be crushing. Let's forget about the fact that our cars already can't tell us how to get from point A to point B well, but it would have impacts on our safety. It would have impacts on the financial world. So in quantum sensing, now you've got, using lasers, you're manipulating atoms, ions, things like that. And you can use it as a sensing tool. So that could be a GPS replacement. And they're working on tools between optical clocks and just general gravitational sensing with quantum that can help replace those potentially at-risk systems. If you think about a quantum computer, we use computers every day, but there's actually problems that we can't solve. And two good examples of problems that we can't solve with computers that we have today. Using that GPS theory again, there's what they call the traveling salesman problem. If a salesman has 300 different entities that they're working with, they wanted to go visit them all. There's not a computer today that can say, what's the most efficient path for me to visit all of these customers? It's just too big of a problem. So it's a complex problem. They're thinking with the introduction of the qubit that those types of problems could be solved. And even tying in a bio example to that. Every time you go into the pharmacy, the pharmacist compares the medication that they're about to give to you to things that they're already familiar that you might be exposed to, because they can't compare it to every medication or a chemical that's out there, because there's not a computer that can do that complex of a computation. So don't necessarily think of quantum computing as a faster computer, but think of it as a more complex problem. And those are just a couple of examples of what quantum is trying to solve today.
Wow. So what I hear is increasing accuracy and really being able to synthesize complex information for the ability to make a life-saving decision.
Those are just some of the goals. That's right.
Just some of the goals. Wow, we're gonna need another program for this. This is a little bit like it isn't on my question list, but now it makes me wonder. I know you've been really known for doing market research and your ability to leverage market research in your strategy. How do you do market research on an emerging market? Like, this just seems so fascinating to me. How can you do that?
Yeah. So what ends up happening is, I mentioned earlier that we're pretty heavy tech push. So we take problems that don't have a solution and try to come up with a solution for them. But the way we typically get that is we launch a product that somebody then looks at and says, hey, that's a really neat idea that you have. Can it do this? And then we make some educated guesses and collaborate with them to see if we can. So it's almost instead of being a market push. So Apple does market push. They go and decide what the world thinks that we need that's best for us, and then they launch a product to it. We actually turn that around into a market pull. So we pull people in with our technology and then look for applications that we can solve with them, where the laser space will make that technology better. And it really takes a strong amount of collaboration. So, and then once we have it, and our markets are relatively small. So we're talking markets that are hundreds of millions of dollars, not necessarily billions yet. And then we target the users in that. So we stay very close to that market. We call it a leader-follower strategy. We stay super close to that market, and we learn who the leading technologists in their field are, and then we offer them tools, and we see if we can solve problems together. So it's a tech push across the board.
The level of collaboration between the business and the customer, it's almost, I've heard of a complex adaptive system. I'm almost thinking there's a complex adaptive solution to that, and just the idea. In the class I teach, exploring innovation, we're really talking about like this co-creation model that's relatively new, and you're just a great example of here's some capabilities. How might you use these capabilities? Let's build them together. That's really a neat emerging market of how the future is going to be built. Any other comments on that before I get back on the script?
Yeah, I think it's a little bit of that if we build it, they will come strategy.
Okay.
So it's not quite that. We don't build things that, I shouldn't say we don't. Sometimes we do build things that we don't know if there's a market for. But almost all the time, it's an adjacent push on the technology to try to bring it to market and see if there's an interest. So it's a kind of a blended, a little bit more of a secure message than the if we build it, they will come. Because we don't think we're that smart. We're great with technology, but we're not awesome at defining a market. So we use our technology to pull the market to us.
Well, I think the humility of knowing what you're best at is really incredible. So you would say, I guess I'll let you say, what do you say your company is the best at?
Oh, we're the best at lasers, all wavelengths, and then making the best for the application. So again, there's many great laser companies out there. But if you look at the breadth of technology that we bring to the market and then the precision of that technology that goes into it, I think that's our expertise. Combine that with the ability to commercialize it. And that's probably key. We do many great things, but when I'm asked most often, that comes down to we figure out how to commercialize it and make it useful. So we don't just make one to prove that it can be done. We make one to prove that it can be done, and then we have that strong ability to bring it to market.
So it can be done at scale. Maybe for many companies, like even Sertl Optics is kind of getting ready for prototype and to scale. What are maybe 3 things that we can learn from your expertise on the commercialization process?
Well, I think you touched on some of them. So first off is teach yourself what you're good at, right? So, and then anytime you're looking at commercializing something, is first of all, define whether or not there's a market. So a market of one isn't a market. Well, technically it might be, but it's not one that's sustainable. So you use that to define whether it's a market. And then you look at the components that you have risk within that system. And you design out or you engineer in the problems that you have with it. So you've got to understand what's impacting the technology that you're manufacturing, and then see where you can design in value engineering that allows it to work in different environments. And that's all engineering. Once you get the physics problem solved, you typically move towards an engineering platform that you design and the solutions that will give you robustness and stability.
So I want to optimize your expertise in not only are you a leader in the technology, but you're also a leader in terms of investment strategy, and mentorship. So what advice would you give to aspiring entrepreneurs and innovators who are looking to break into the deep tech industry?
Yeah, so as you're looking to break into deep tech, I think you have to find customers first. So again, that's where I come back to. It's rare that we'll just go out and invent something because we want to invent it. Normally, it'll be close to, we encourage our people to take risks. So they don't need to ask permission when they want to try a new idea. They just go and execute it. But then we always we step backwards and say, okay, is there somebody that actually wants this technology? Too often when I see emerging companies or emerging technology ideas, they've got a great idea. They just don't know what to do with it. So they've got to pair that's key for business. They've got to pair their idea with somebody that might want it. If you don't find somebody that wants it, then you don't have a company. And end of discussion on that topic. And so many actually miss that. They come up with a great idea, and it seems almost commonplace that you need to be able to sell it. But they go with that strategy that if they build it, they will come. And that's not always the case. So it's really defining and looking at who your customer might be or just who a user is. So many people forget to do that.
We have a saying that I learned from one of our engineers is that the idea of break the pencil. When you work with people that really like building things and exploring possibility, there's almost too much. Can you imagine an environment where there's too much iteration? But there is environments where there's too much iteration. You sometimes have to break the pencil, right? Let's just talk about you and I know there's probably many, but can you share one of the most rewarding professional experiences that you've had, and also what keeps you motivated and pushing forward?
Yeah, that's actually, it's a complex question, but it's kind of easy too. I call it our cool factor. And it comes back to a time a number of years ago as we were early in the days at Toptica. I was having a conversation with my office manager, and he looks at me and says, "You're one of 3 people that I know that absolutely loves what they do." And I had never thought about it, but he was right. And the reason that I love what we do and this is true with most of my career, is I go tech push. So I love the technology. And I've been involved in other industries. For a number of years, I shifted into a field that was very fulfilling, and monetarily, I did fine with it. So it was alternative energies prior to coming to Toptica. The challenge that I had with it is that it wasn't technically fulfilling. So the technology component was something that was important to me. That's not important to everyone. But then the cool factor is what kicks in. By cool factor, I mean, what are the applications that we are impacting the world? So we talked about quantum, and your imagination could just go wild thinking about the things that will do. But we get into biophotonics, and our lasers are used for applications for HIV research, high throughput screening, DNA sequencing. Those are having a real impact on the planet today. We get into the materials. We get involved with technologies that, you can use our lasers for making holograms on optics. And you think about heads-up displays and AI that's coming with that, knowing the impact that you're having. One of my most fun examples, I mentioned earlier that I had aspirations of going into space. Well, I don't know if that'll happen. Maybe someday that still happens. But we have a guide star laser that goes on many of the giant telescopes across the planet. And that's used as a tool to allow those telescopes to see through the atmosphere. But the reality of it is they estimate that within my lifetime, those lasers will help define whether or not there's life in galaxies where we think there might be. That's awesome. That's all cool factor. And that's what our lasers enable. We may not get credit for it ever. Who cares? But knowing that my work that I do every day goes into something that's having an impact on society, I don't need buildings named after me. That's a nut right there. That's the cool factor that keeps me coming back every day. And even right now, as I say this to you, I get goosebumps.
It's palpable. I can imagine. It just seems like it would be so easy to get talent with that kind of clarity on mission and the capability that are there. And I'm also wondering if you're on a list for SpaceX. Are you on a waiting list for SpaceX to go up into space?
I'm not. So I'd be happy to have you put me on one.
That's really wonderful. You have been you've been listening to Mark Tolbert from CEO of Toptica, and we've been talking qubit. Is it qubits?
Quantum technology using qubits. Sure.
Okay, quantum technology using qubits, emerging markets, customer discovery, and really like AWE, which is great. Thanks for joining us. We'd like to thank the Institute of Optics, Genius New York, Luminate Accelerator, AFWorks, Cider Technologies, Archangel Imaging, and AUVSI. Special mention to our producer, Scott Fitzgerald at RockVox Studios in the heart of optics expertise here in Rochester, New York. By all means, subscribe to our program. Find us on Twitter and LinkedIn. We're very interested to know how immersive technology positively impacts safety and human connection, like we heard here today. And if you know a story we should feature or a guest that can further this conversation, please let me know. You can reach me at jennifer@sertloptics.com.